Here's a solution I made by dissolving 0.1 grams of tin chloride in 5 milliliters of HCl. And it looks great. But if I were to scale this up, it will result in unreasonable quantities of acid needed. Let me show you how that works mathematically. So this is a ratio that worked, gave me a nice solution, but it's not an optimal ratio. If I were to say, let's go 10 times higher, then this will be 1.0 gram of tin chloride. But then I'll need 10 times more of that, 50 milliliters of HCl. And this is starting to become a lot of acid for a very little amount of salt. And you should realize you're trying to go all the way up to 20 grams of salt. And what would that mean on this side? 20 times 50? 20 times 50, that's 1,000 milliliters. That's a whole liter. So clearly this is absurd. And that means that the original ratio, this original ratio, is not the ideal ratio. So you need to do experiments to say, well, I probably didn't need 5 milliliters of HCl. Probably could have dissolved that 0.1 grams in much less HCl. Or probably could have dissolved a lot more salt in this HCl. So the optimal ratio is not what I did. I'll have to experiment, either trying to dissolve this in less HCl, or say, well, how much can I dissolve in 5 milliliters HCl? So you do that by experiment. Maybe I can put 1/10 of a gram of the tin chloride and just try 1 milliliter of HCl. Or I can try 0.2 grams in here, trying to find the minimal quantity of acid needed to dissolve a small quantity of this salt.